in high school, would sort of blurt things out. And, I call that interesting, but they called that disruptive. Yeah, my passion for science really probably begins with my father being an engineer, and when we would go on a family vacation to the mountains, most families would take a walk in the woods on a trail, and we would stop at a dam for hydroelectric power, and my father would point out that's where the generators are, and that's where the water is held, and that's potential energy, and that sort of thing. And that was, probably when I was 5 years old. But it sort of really got launched big time by the U.S. space program, which is not unique to me by any means. It was essentially my whole generation was inspired by that. And that was early television, because I'm born in 1952. So the space race begins really in around 1961. And so watching launches when I'm 9 years old, that means waking up at 4 a.m. to watch the launch. And, the space program was about showing the Soviet Union that we're better, right? It was all propaganda. Well, much of it was propaganda, because there was no good reason to go to the moon. There was no real reason to go. And it ended up being 4% of the US gross national product being spent on this. So it was a huge expense. And it was symbolic, and to say, look, we have missiles and we have nuclear weapons, be advised, don't mess with us. And that's how it got approved. But what it ended up doing was inspiring a bunch of 10-year-olds and 8-year-olds and 14-year-olds and the American scientific revolution. Now we think of America as this technological marvel. If Silicon Valley has this mythic status, now molecular biology and biotech, it gets launched by the US space program. That was not the intent, but it was worth the 4% of the gross national product. Well, it teaches us that Earth is a dot, and that the solar system is a dot. And, we're going to Jupiter was a big deal, right? We sent a spacecraft to Jupiter when I was 20, maybe. I had nothing to do with it, but I could watch and be in awe of it. And by the way, John Cassani, the chief engineer of that mission to Jupiter and Saturn, he rode in the back seat of my car from Woods Hole to Boston, Massachusetts 30 years later. And you'd have to pinch me. I had the chief engineer of a project that I thought was the most awesome project in the history of science, and he's in my back seat. I was smiling a lot, 2 hours of driving. I embarked on a full year trip, again, third-class buses, all the way across Mexico, Guatemala, Nicaragua, down to Panama, onto the Amazon River, down the Amazon River in a riverboat, that's $12 to go 800 miles. This is not first-class travel. The way you sleep on this riverboat is by hanging your hammock outside from a bar. And if it's calm, you have a lovely moment on a hammock, but the Amazon is like an ocean. And when it's windy, the hammocks are banging into each other. It was, and it's, this is a working class transport. And, then 1,000 miles on the Trans-Amazon Highway, but that's not a highway, it's a dirt road at that point. I don't know what it's like now. But then to Carnaval, which is the great partying tradition, almost like the Stockholm all-night party, except it goes on for a whole city. And that was in Salvador de Bahia, which is a famous place to go for Carnaval. So, lots of travel. And what happens when you travel is you meet other travelers, for sure, who are quite expert at how to navigate your way. Because they have guidebooks, but they don't really tell you the real dope on how to do it. And so you end up talking to other people, and of course you meet people on the road. Uh, but you kind of learn how to read people quickly and befriend people or not. And that happened a lot. And that helped me for the rest of my life with sort of instant assessment and instant bonding with people. And that it happens in my lab, right, where I have to assess people and I entertain them. I have good stories to tell, and it's good to not be boring. And so that's, I do have a kind of 100 stories that I'll tell over and over and over again. In high school, I was not the most outstanding student, from age whatever it was, 15 to 18 or 14 to 18. And a great concern to my parents was that you would be graded on your behavior. And unsatisfactory was like you're really misbehaving and disrupting everything. I did not get that, but a W means warning. And that means you're at the edge of unsatisfactory. And because I was noisy and, would sort of blurt things out. And, I call that interesting, but they called that disruptive. And my father is not disruptive, and so he would lecture me about these citizenship grades. Yeah, it's a kind of normal thing to not be entirely sure where you're headed. It's a different era. When I went to college, it was 1969 to 1973. It has some similarities to today because there's a lot of political activities. In the U.S., it was about the Vietnam War, which was a very unpopular war, and it haunted males of my generation. I could have been drafted into the Army, and I had a number. There was a lottery, and my number, I think, was 121, if I remember correctly, and they got down to maybe 60 that year. And it's a random lottery who gets in. It was never really high odds that I was going to be drafted, but I know people in science who did get drafted and did go to Vietnam. And that level of political activity, I was at Berkeley, which is a very active university. It had what was called the free speech movement in the early 60s, so it was well known for being politically left wing. I didn't participate as much as many of my friends did because I was such a nerdy science guy. I wanted to make sure I was learning what Berkeley had to offer in its courses. And I think too many people get completely distracted by sort of social conventions. All of our instincts are not perfect. And so you have to watch out for those instincts. And to me, universities are a cultural evolution that has happened in the last 1,000 years, and they're remarkable and helpful. Should have been worried about my career, but I think they had other things that were grabbing their attention more, and so they figured I would work it out. I think they were happy that I had reasonable grades in the university. So I think they were happy that I went through Berkeley and didn't mess up. And I think they understood that sort of when I go and plant trees with a cooperative in Oregon and go to Latin America for a year, that's kind of what 21-year-olds and 22-year-olds do. But it was not a clear career path by any means. And I think they were fine with that because the whole generation was behaving that way. So they kind of decided, he's just part of that generation they'll either find out how to do it right or they won't. Yeah. Well, my education in science was colored by focusing on physics for a couple of years. And at Berkeley, the physics professors were sort of mythic status. Berkeley was where J. Robert Oppenheimer worked before the Manhattan Project. So it was very big in nuclear physics and quantum mechanics. And so I learned physics is taught, interestingly, in a historical fashion. Biology is not, which I think is a mistake. Because physics is taught historically, you sort of see how people did things in 1800 and 1880, and all of a sudden in 1920 there's a revolution, which is quantum mechanics. Comes mostly out of Germany. Very mathematical, and I barely understood it, but I did understand it. And what I really understood was what a scientific revolution is, and that was a scientific revolution. And so when I got to graduate school, again, I didn't have a vision of what I wanted to do. I sort of knew that biology was exploding. I had a kind of an instinct. It really wasn't knowledge. It was kind of an instinct. And then when I got there, it was clear it was exploding. And I started to really learn, again, the history, 10-year history of the double helix, which was sort of a 1953 discovery. Nobel laureates, Francis Crick, James Watson, Maurice Wilkins, and then the genetic code and how that was solved. And so these were earth-shattering discoveries, and just knowing, experiencing what was important, and then having role models as in my graduate program who were scientists who just were icons and people that I could watch how they think and how they really think about science. And so I had 5 years of watching it. And the way I think about graduate school, it's not a lot of coursework, at least the way we did it, but you see something like a seminar a week, often from somebody who's really profoundly great. Not all of them are great, but half of them are great. And so if you're 5 years of doing that, you see something like 100 awesome examples of science, very diverse. Somebody's working on yeast, somebody else on bacteria, somebody else on a monkey, all these different things. And you just have examples. And, I know I explicitly in my PhD imitated a few of the examples I saw and said, I think I can apply that to what I'm studying. Yeah, so Victor Ambros and I met day one of my postdoc. So I go to Bob Horvitz's lab. Bob is he's probably 32 years old at that point, maybe a little bit less. And he just starts his lab. His lab has been going for maybe 2 or 3 years. And just a little anecdote, he was friends with the Fred Ospel, who I did my PhD with. And before I contacted Bob about going to work with him as a postdoc, Fred Ospel, my boss, had said, Bob Horvitz is moving and he needs somebody to help him move. Can you help? So Bob saw that I did heavy lifting. And that, that's sort of a subliminal thing that you say, oh, he's a hard worker, So I show up at the lab and Bob says, well, here's a project we're thinking about. And Victor Ambros has just started working on it. And so Victor and I start talking and we get along really well. And we work together for 3 years while we overlap as postdocs in Bob's lab. And then when Victor gets a job a mile away, 2 kilometers away from where I get a job, we continue to collaborate because we're close by. Well, he's very understated. He doesn't sort of beat his chest on how brilliant he is, but there's constant discovery, and every time you talk to him, you can see a raw intelligence and broad reading. And so, when you see somebody who's creative and well-educated, it's great. And it's been like that for 40 years. What collaboration in science means is that people work on related topics. It doesn't mean you're working together so much as somebody communicates a result from a rice plant, and it uses some of the similar components to the things we are working on in a worm, and it makes us realize how it works in the worm, and it makes them realize how it works in a rice. The thing to think about is humans have something like 25,000 protein coding genes and probably 1,000 microRNAs. So microRNAs are sort of 5% or whatever that is, 3% of the genes in a human. And then a worm has the same number of these genes. But it's not that the worm has a different collection. Most of the worm genes are related to the human genes. Most of the human genes are, exactly the same in primates, and about half of them are the same in plants. So that the currency of genetics, like what's in play to make an organism happen, is a very small number of genes. So think about it as 20,000 genes on the planet. And there's 500,000 molecular biologists. So there's more of us than there are genes. So any gene we work on, when we get a mutation, you can instantly say, oh, somebody worked on that in bacteria, or somebody worked on a related gene in a plant or a fungus, and that's informative. Now, it's slightly competitive because you can get scooped by those people and vice versa, but it's much more informative than competitive. So a single postdoc in my lab now will discover 30 genes in a year or two. And it used to take a lab of 20 to do that for 10 years. So things got accelerated. And that means the risk for doing anything is suddenly decreased. So if it fails, if you do something and you say, oh, I can't make sense of that, 2 weeks later you do something else. And so it's good to work in a system that allows risks. And so we do that. We gamble a lot when we do our genetics. The other thing about genetics that people fail to appreciate is that when we're doing genetics, we're looking for variation in genes that we induce with mutagenesis usually. But that variation is the same thing that happens in evolution. The way all the diverse birds you see have been generated is by variation in genes that selects for this color and that behavior. And so what's made the world a special place, the reason we have an oxygen atmosphere, is that photosynthesis evolved, and it evolved by genetic change. And it's not a geneticist doing it, it's just random variation, it's survival of the fittest. We as geneticists are just doing survival of who we care about. So we select for this and that, and we say, I want to look at that, and I'll do a genome sequence of that. But the reason it works so well is the reason that the Earth has, 1 billion different species. Genetics really works. So is cooking related to science? Working at the bench is very much, adding things to tubes and following recipes. And before I did that, I did cooking. So I probably learned to cook in the Boy Scouts. And the Boy Scouts, was a way to go up and go hiking, and I enjoyed that. But that taught me how to cook. You get merit badges. You wear a little sash, and you have little badges, and and so I got a merit badge in cooking. Which really means you know how to put hamburger in foil and stick it in a fire. It's not great cooking. But for example, I have a recipe for Mexican chicken that I'm quite proud of. And that recipe evolved when I ate at a Mexican restaurant in Houston and really enjoyed their sopa de gallo. And I sat there in the restaurant, slurping it like the people slurp wine to try and say and I tried to figure out what was in it. And I even entered my Mexican chicken recipe in a contest at Mrs. Renfro's habanero sauce, which I lost. So I'm an award-losing cook. It was a tragedy because I should have won. It was a miscarriage of justice, I still think. Uh, and I now my goal has been to get firemen and women who are famous for cooking in the firehouse because because eating is what they do between fires. And I've been trying to get them to make my Mexican chicken or let me make it for them. So that we've been trying. My daughter is a medical student, and she went out with the emergency medical services. I say, "Can you pitch my Mexican chicken to them? I'll make it for them." I think they didn't find it credible. It is the day of the Nobel Prize. My longtime administrator, she's Diane Sacchetti, has worked with my lab for almost 30 years, and helps put the grants together to submit to get money and does all the administrative work of ordering for the lab, but also is like a friend to everybody who's ever worked in my lab, and people love Diane. And she's a close family friend along with her husband and children, Frank Sacchetti and Carissa. And Frank runs ice cream trucks all over Boston. It's called Frosty Ice Cream. And it's the kind of truck that will pull into a park on a hot summer day, and it'll play. I don't know if they do it in Sweden, but they play the kind of plinka, plinka, plinka music, and everybody knows the truck has arrived. And my daughter and I have worked on the truck a few times just for fun. And it's super fun to do because when you make the little frosty cone and hand it to the person at the window, they can be 80 years old, but they look like they're 8 years old because they're happy to get an ice cream cone. And so Diane said, "Can I have Frank come the day of the Nobel Prize?" So after the press conference that we had, where I work at Massachusetts General Hospital in the parking lot, there was Frank's truck with Frank Jr., and I climbed on and started serving it to people. And it was hundreds of people who are scientists who work in our lab, but it was in our parking lot of our institute at Massachusetts General Hospital in Boston. That video had a bazillion hits, right? Everyone likes a frosty cone.